Another idea is to get 2 phones, so you'd have to have a phone to do this one again. But you can get a phone and you can put it in different locations and you can wrap aluminum foil around it. There was one where Physics Girl, I put it on the website, but she puts her phone in the microwave to see if it can pick up a signal. So if you put your phone in different places, make sure you check the aluminum foil, the microwave. Of course, don't turn on the microwave while your phone's in there. Just see if it picks up a signal. So have somebody else call your phone to see if it's picking up the signal. So we've all been somewhere where this phone isn't picking up a signal, and so we miss a call or whatever. So you're just going to have a friend or somebody call you while it's in these different locations, and you're going to see if it can pick up that radio wave or microwave, or if it doesn't. So essentially what you're doing with the cell phone lab is you're measuring the transmission of these microwaves and how you can block it. So that's another lab that you could do for this. Okay, I wanted to give you a couple of quick suggestions. Obviously, you can do whatever you want on this, but you could just double up some clear plastic cups onto your sensor and notice the pattern that creates. So it could be something just easy like this, where you keep adding them to see how that is causing a difference in the transmission of light. Remember, transmission is one of our vocab words. I really wanted you guys in your conclusion to use those vocab words to practice. So you could do something like this. You could also just get some tape. Just, 1 piece of tape. What does that do? 2 pieces of tape. What does that do? You could do reflections. So, or you could take your sensor around and pick up light in different places. All right, here's another idea you can do for your light lab, so your EM wave lab. So if you don't have a phone where you can measure with light intensity, it doesn't matter. There's lots of things you can do. So one is you can see this is emitting light, so radiation in the form of light waves. So it's something easy for us to observe because we have eyeballs that pick up on this radiation. So you can say, at 0.1 centimeters away from the paper, this is the area of the circle. And then as you move it back, so now at 1 centimeter away from the paper, this is the area. At 2 centimeters away from the paper, this is the area. At 3 centimeters away, this is the area. At 4, 5, 6. So you can see when I move it away, so what is that relationship? So what the question is, as you move a light source away from an object, how much scattering is occurring? So the light is going to disperse. It's going to spread out. It's going to be reflected off of everything, this is not a laser light. It's going to be dispersed. So what is the dispersion rate as you move it away from your paper? So you can see it up on the board a little clearer. So as I move away, we all see that it gets bigger. So what you'd be doing is figuring out what rate. So that could be another lab. All right, another low-tech lab you could do is about reflections and mirrors and how they bounce light around. So I don't know if you can see me in that mirror. There I am. But notice the size of my iPad. So when I get closer, what happens to the iPad? It gets bigger. But you can get some quantitative data, and you can actually measure the distances and measure the size it is in the mirror. That could be another lab. I hope this was helpful. I hope you have a few ideas for what to do, and good luck. And of course, as always, if you have any questions, email me. And I always check my emails and I can reply as soon as I get it. Thanks.